So Synthon-Retrosynthesis, it's a chemistry topic. So what is the meaning of retrosynthesis? Retrosynthetic analysis is a technique for solving problems in the planning of organic synthesis. Okay, as you have seen, we have many organic compounds. Okay, we have, like, for example, at that day I was discussing the benzodiazepine, right? So diazepam, if I draw the structure of diazepam, I have drawn the same structure earlier. Okay, this will be the structure of diazepam. So what happens if I want to synthesize this structure? Okay, so this retrosynthesis helped me. Now you have a concept of convergent synthesis and the linear synthesis. The convergent, okay, convergent synthesis, so, and the linear synthesis. So convergent synthesis has the advantage of generating higher yield compared to a linear synthesis. In convergent synthesis, key intermediates are prepared separately and then joined to form product. Like, for example, I have to synthesize B, okay, from A and plus C, okay, suppose. So now I have to synthesize A separately from X plus Y and the C separately from A plus B. So then I am making A plus C together to form B. So this is a convergent synthesis which increases the yield of the compound, rather than if I go for a multi-step synthesis, a linear synthesis, where it is X plus Y is equal to Z plus A is equal to B, then last, I get the product. So it's not like that. So then the reaction condition, temperature, solvent, reaction time is very important. A synthesis can be stereoselective reaction like Sharpless epoxidation. So retrosynthesis is invented by the scientist James Corey, and he got a Nobel Prize in 1990 for developing retrosynthesis techniques. Okay, retrosynthesis involves the method of disconnection. It involves the method of disconnection, okay, of a molecule to a particular bond to generate synthon, okay, to generate synthon, which can be converted into synthon equivalent, which also known as reagents, okay, synthon equivalent known as reagent, okay. And this synthon equivalent can be formed with or without functional group interconversion, FGI. So now let me discuss how to go for a disconnection method. So see, for example, I have a CX molecule, okay. So this is R3 CX molecule. Now if I want to disconnect the CX bond, then I'll be having a C plus and X minus. This is my synthon, okay. This fragment is synthon, where the plus are known as synthon acceptor, okay, acceptor, and X minus, they are known as synthon donor. And every acceptor has to be converted into synthon equivalent. Like suppose it is R plus, so my synthon acceptor will be converting into RCl. Suppose it is CH3 plus, so methyl chloride is my reagent or synthon equivalent. So this is very important understanding before we'll go for method of disconnection to synthesize the molecule. Okay. Now the moment you know the different synthon, equivalent and synthon acceptor and donor, then what is the strategies? Strategies to explain the synthon is, suppose I have a molecule like this, okay, double bond phenyl, right? Now if I can go for an FGI, functional group interconversion, OH. Okay, I simply go for functional group interconversion, and then I go for disconnection with CC bond. Okay, now the next question is, people ask that where to disconnect. Okay, in where to disconnect, see, you can disconnect the bond, okay, after a carbon where the functional group of E class is attached. See, this is the functional group E class. So any carbon which attached to E functional group, that carbon, okay, to the next carbon or next functional group, the bond can be disconnected. That is to get a synthon. So if I disconnect, then what are the two important synthon I get? I use white. I'll get one minus, this is donor synthon, and one OH plus pH. This is acceptor synthon. Now OHC plus, if you see OHC plus, you will find over here, you see OHC plus. Okay, now I have attached to a phenyl, so it should be converted into aldehyde. So if I want to convert the synthon equivalent, okay, then what will be my structure? Synthon equivalent, I'll be having double bond because it's aldehyde, and one phenyl group is attached. So this is my reagent number 1. Okay, and this can be converted into MgX, Grignard. Okay, like minus, I have told you R minus RMgX. So this is the second reagent. So then first and second, if you combine them, okay, with a proper reaction, and that's how you require the basics of organic chemistry. If you are new to this channel, please go to the organic chemistry name reaction, okay, how, and also the mechanism of the reactions. You have a name reactions, and before that you have a mechanisms of that reaction, like electrophilic substitution, nucleophilic addition. So these two are my starting material for producing the desired molecule. Now the next can be disconnection without the functional group interconversion. Like suppose I want to disconnect this molecule without FGI. So my E functional group is double bond O. This is okay. So this carbon to the next carbon, this will be my disconnection area. Okay. G carbon, see, E carbon attached to a C plus, that means your acceptor, and G functional group attached to a donor synthon. So we